The Holocene is the geological epoch that began after the Pleistocene at approximately 11,700 years before present. The Holocene is part of the Quaternary period. Its name comes from the ancient Greek words lambda omicron sigma, holos, whole or entire, and kappa alpha iota nu omicron sigma, kainos, new, meaning entirely recent. It has been identified with the current warm period, known as Mes 1, and is considered by some to be an interglacial period. The Holocene encompasses the growth and impacts of the human species worldwide, including all its written history, development of major civilizations, and overall significant transition toward urban living in the present. Human impacts on modern-era Earth and its ecosystems may be considered of global significance for future evolution of living species, including approximately synchronous lithospheric evidence, or more recently atmospheric evidence of human impacts. The International Commission on Stratigraphy Subcommission on Quaternary Stratigraphy's working group on the Anthropocene, coined by Paul Crutzen and Eugene Stoermer in 2000. Note this term is used to denote the present time interval in which many geologically significant conditions and processes have been profoundly altered by human activities. The Anthropocene is not a formally defined geological unit. Overview. It is accepted by the International Commission on Stratigraphy that the Holocene started approximately 11,700 years ago. The Subcommission on Quaternary Stratigraphy quotes Gibbard and Van Kolfschoten in Gradstein Og. and Smith in stating the term recent as an alternative to Holocene as invalid and should not be used, and also observed that the term Flandrian, derived from marine transgression sediments on the Flanders coast of Belgium, has been used as a synonym for Holocene by authors who consider the last 10,000 years should have the same stage status as previous interglacial events and thus be included in the Pleistocene. The International Commission on Stratigraphy, however, considers the Holocene an epoch following the Pleistocene and specifically the last glacial period. Local names for the last glacial period include the Wisconsini in North America, the Vixalian in Europe, the Devensian in Britain, the Clanquihue in Chile and the Oteran in New Zealand. The Holocene can be subdivided into 5 time intervals, or chronozones, based on climatic fluctuations. Pre-boreal, 10 Ka 9 Ka, boreal, 9 Ka 8 Ka, Atlantic, 8 Ka 5 Ka, subboreal, 5 Ka 2.5 Ka, and subatlantic, 2.5 Ka present. Note: Ka means 1,000 years. Non-calibrated C14 dates. The Pleistocene, and a classification of climatic periods defined initially by plant remains in peat mosses, is now being explored currently by geologists working in different regions studying sea levels, peat bogs and ice core samples by a variety of methods, with a view toward further verifying and refining the Pleistocene and a sequence. They find a general correspondence across Eurasia and North America. Though the method was once thought to be of no interest, the scheme was defined for Northern Europe. But the climate changes were claimed to occur more widely. The periods of the scheme include a few of the final pre-Holocene oscillations of the last glacial period and then classify climates of more recent prehistory. Paleontologists have not defined any faunal stages for the Holocene. If subdivision is necessary, periods of human technological development, such as the Mesolithic, Neolithic, and Bronze Age, are usually used. However, the time periods referenced by these terms vary with the emergence of those technologies in different parts of the world. Climatically, the Holocene may be divided evenly into the hypsothermal and neoglacial periods. The boundary coincides with the start of the Bronze Age in Europe. According to some scholars, a third division, the Anthropocene, has now begun. Geology. Continental motions due to plate tectonics are less than a kilometer over a span of only 10,000 years. However, ice melt caused world sea levels to rise about 35 meters, 115 feet, in the early part of the Holocene. In addition, many areas above about 40 degrees north latitude had been depressed by the weight of the Pleistocene glaciers and rose as much as 182 meters, 590 feet, due to postglacial rebound over the late Pleistocene and Holocene, and are still rising today. The sea level rise and temporary land depression allowed temporary marine incursions into areas that are now far from the sea. Holocene marine fossils are known, for example, from Vermont and Michigan. Other than higher latitude, temporary marine incursions associated with glacial depression. Holocene fossils are found primarily in lakebed, floodplain, and cave deposits. Holocene marine deposits along low-latitude coastlines are rare because the rise in sea levels during the period exceeds any likely tectonic uplift of non-glacial origin. Post-glacial rebound in the Scandinavia region resulted in the formation of the Baltic Sea. The region continues to rise, still causing weak earthquakes across northern Europe. The equivalent event in North America was the rebound of Hudson Bay, as it shrank from its larger, immediate post-glacial Tyrrell Sea phase to near its present boundaries. Climate has been fairly stable over the Holocene. Ice core records show that before the Holocene there was global warming after the end of the last Ice Age and cooling periods. But climate changes became more regional at the start of the Younger Dryas. During the transition from the last glacial to the Holocene, the Hugh-Elmo-Mascardi cold reversal in the southern hemisphere began before the Younger Dryas, and the maximum warmth flowed south to north from 11,000 to 7,000 years ago. It appears that this was influenced by the residual glacial ice remaining in the northern hemisphere until the later date. The Holocene climatic optimum, HCO, was a period of warming in which the global climate became warmer. However, the warming was probably not uniform across the world. This period of warmth ended about 5,500 years ago with a descent into the neoglacial and concomitant neopluvial. At that time, the climate was not unlike today's, but there was a slightly warmer period from the 10th–14th centuries known as the medieval warm period. This was followed by the Little Ice Age, from the 13th to 14th century to the mid-19th century, which was a period of cooling. Compared to glacial conditions, habitable zones have expanded northwards, reaching their northernmost point during the HCO. Greater moisture in the polar regions has caused the disappearance of steppe tundra. The temporal and spatial extent of Holocene climate change is an area of considerable uncertainty, with radiative forcing recently proposed to be the origin of cycles identified in the North Atlantic region. Climate cyclicity through the Holocene bond events has been observed in and near marine settings and is strongly controlled by glacial input to the North Atlantic. Periodicities of approximately equals 2,500, approximately equals 1,500, and approximately equals 1,000 years are generally observed in the North Atlantic. At the same time, spectral analyses of the continental record, which is remote from oceanic influence, reveal persistent periodicities of 1,500 years that may correspond to solar activity. Variations during the Holocene epoch, a 1,500-year cycle corresponding to the North Atlantic oceanic circulation, may have had widespread global distribution in the late Holocene. Ecological developments. Animal and plant life have not evolved much during the relatively short Holocene, but there have been major shifts in the distributions of plants and animals. A number of large animals, including mammoths and mastodons, saber-toothed cats like Smilodon and Homotherium, and giant sloths disappeared in the late Pleistocene and early Holocene, especially in North America, where animals that survived elsewhere, including horses and camels, became extinct. This extinction of American megafauna has been explained as caused by the arrival of the ancestors of Amerindians, though most scientists assert that climatic change also contributed. In addition, a controversial bolide impact over North America has been hypothesized to have triggered the younger dryas. Throughout the world, ecosystems in cooler climates that were previously regional have been isolated in higher altitude ecological islands. The 8.2 Ka event, an abrupt cold spell recorded as a negative excursion in the Delta 18O record lasting 400 years, is the most prominent climatic event occurring in the Holocene epoch, and may have marked a resurgence of ice cover. It has been suggested that this event was caused by the final drainage of Lake Agassiz, which had been confined by the glaciers, disrupting the thermohaline circulation of the Atlantic. Subsequent research, however, suggested that the discharge was probably superimposed upon a longer episode of cooler climate, lasting up to 600 years, and observed that the extent of the area affected was unclear. Human developments. The beginning of the Holocene corresponds with the beginning of the Mesolithic age in most of Europe, but in regions such as the Middle East and Anatolia with a very early Neolithization. Epipaleolithic is preferred in place of Mesolithic. Cultures in this period include Hamburgian, Fademesser, and the Natufian culture, during which the oldest inhabited places still existing on Earth were first settled, such as Jericho in the Middle East. There is also evolving archaeological evidence of proto-religion at locations such as Göbekli Tepe, as long ago as the 9th millennium BCE. Both are followed by the Aceramic Neolithic, pre-pottery Neolithic A and pre-pottery Neolithic B, and the pottery Neolithic. The late Holocene brought advancements such as the bow and arrow and saw new methods of warfare in North America. Spear throwers and the large points were replaced by the bow and arrow with its small narrow points beginning in Oregon and Washington. Villages built on defensive bluffs indicate increased warfare, leading to food gathering in communal groups for protection rather than individual hunting. See also. Further reading. Roberts, Neil, 2014. The Holocene, An Environmental History. 3rd ed. Malden, M.A., Wiley-Blackwell. ISBN 978-1-4051-5521-2. Mackay, A. W. Batterby, R. W. Burks, H. J. B. al. eds. 2003. Global Change in the Holocene. London. Arnold. ISBN 0-340-76223-3. Hunt C.O. and Rebecca J. 2013. Holocene Landscape Intervention and Plant Food Production Strategies in Island and Mainland Southeast Asia. Journal of Archaeological Science. The Holocene Epoch Explained by the BBC. GHK Classification.